Hello, intelligent beings of the etherweb. Moscow government in past years went on a craze to install as many public USB chargers as possible. This craze came to my mind when I was preparing another story. I thought of those questionable public USB chargers and thought of an experiment. Those chargers always were associated with trouble for me, be it from what I've read or what I've experienced, but I've never done a proper look at them. Since a few years ago, I've had laying around two identical USB voltage and amperage meters. Those are often used by people like Big Clive for checking power banks and power supplies, and those seemed like great tools to check the big power bank of Moscow. Those are much more handy for the task than a pure multimeter, and don't look as suspicious as a multimeter with probes would in public spaces. Finding a proper load was trickier. Ideally, a modern device that can pull 2 amps would be preferred for authenticity, but I didn't want to subject any of the devices of value to the test, while watching an artificial load would look suspicious and not be authentic. The answer came in the form of a power bank that I've been using to test the meter. This 10,000 mAh Xiaomi Mi power bank bought in Moscow I found to be using only as a backup, rarely traveling with it. Losing Xiaomi wouldn't be a tragedy, and it is a very authentic load. According to the specifications, it outputs 2 amps and charges at 2 amps too, and during the test, Xiaomi Mi charged at steady 1.5. For the best results, the power bank should have been discharged, and so I connected it to a few discharged devices laying around. The final setup for the test also included the original Xiaomi short charging cable. The target was as follows. A public USB charger should be able to provide steady 5V supply with at least 1 amp of current, and if higher is specified, I generously allowed the target to be 1.5. With that, wearing a mask, I went outside in late summer 2020. I planned a route that should have included multiple public USB charger installations in and outside the city center, all commissioned by the city government. This is important, as I had no interest in checking chargers in cafes or restaurants. Those weren't installed using budget funds. I also was not planning to do an exhaustive check, instead planning more of an authentic review of what one might realistically experience in Moscow. The first stop was a bus stop. Since 2016, Moscow government had been installing fancy bus stops with USB chargers, displays and Wi-Fi connectivity on a few streets. Ryazansky Prospect Avenue is one of those streets. Thanks for a bus that have just left, I could easily check the USB chargers without suspicious looks. There are 4 sad-looking USB ports located on a panel. The first USB port greeted me with inconsistent results that could be approximated to 0.6 at 4.8 volts. The second USB port had even more inconsistent results, due to a poor connection and how rattling the USB port mount was. The third USB port provided no output. Instead, when connecting, the light was flashing, with the display flashing as well. The same result happened at the top port, with the meter briefly lighting up and then going back to flashing. This fortunately did not kill the meter, but as we can see, it took just few years for that particular bus stop to lose half of its USB ports, and have poor results on 2 that are working. The ports are simply poorly designed and are rattling. The panel looks as if it was there for not a few years but 20. The ports can easily be tampered with, and while the stop has a camera, if someone were to tamper with the ports, the camera would look at their backs blocked from the view. Soon, a long articulated bus had arrived. The model is Lyaz 6213.65, built in 2018 and serving since April 2019. The bus is on a route M63 that replaced Trolleybus 63. New buses in Moscow, operated by Mosgortrans, Moscow Tram, Bus and previously Trolleybus Authority, all have USB chargers, and this one is no exception. This mount has 2 ports, one labeled 1 amp and another 2.1 amps. Let's begin with 2.1. Doesn't look like 2 amps to me. More like 0.8 amps at 4.9 volts. And it got worse on a second attempt, dropping to 0.5 amps at 4.8 volts. The 1 amp port fared better, actually reaching 1 amp at 4.9 volts, becoming the first that passed the current test. Instead of staying in a bus and probing all the available ports, I disembarked at a stop adjacent to Okskaya metro station. The 2 pavilions at the stop also have USB ports, but they are newer and with different, perhaps better mounts to the ones previously tested. All the ports are labeled 2.1 amps, and the lower port was the first one that passed extended requirements, outputting closer to 1.7 amps at 5 volts. The second port went up to 1.3 amps. The third went up to 1.4. The top one went nothing, because there was no actual port, the hole was empty. Oksky metro station had opened in March 2020 on a new Nekrasovskaya line. It is one of the newest Moscow metro stations. The station itself has no USB chargers, but the trains on the line do. Those are the newest Moskva series trains introduced in 2016 by Metrovagon Mash plant. And the models on the new line are the newest of the newest belonging to the model labeled Moskva 2019. The trains have a fancy corner with USB chargers and a touchscreen route planner, if you ever wish to know how the stations are labeled in simplified Chinese. Moskva series trains caused me my main disappointment with public USB charging a couple of years ago, as the only time I tried to rely on those, the phone did not charge. This newest train continued to disappoint. Despite the fancy LED animation, the train, supplied from 750 volts DC, only managed to pull 0.5 amps at 4.8 volts. The next port looked even worse at 0.2 to 0.3 amps. The same can be said about the top port. The bottom port topped at around 0.46 amps. I disembarked at the next Stakhanovskaya station since I'd never been there and was curious. Whose idea was putting a timer behind the light like that? The approaching train was also Moskva series, but not the 2019 revision. This USB panel is exactly like the one that disappointed me 2 years ago. The results were slightly better. Perhaps with less power needed for the animation, the bottom port pulled 0.7 amps at 4.9 volts. However, the second port only went up to 0.4 amps at 4.8 volts. The third port was the best so far, with 0.85 amps at 4.9 volts. The top port lost connection for a moment, but in general provided 0.6 amps at 4.9 volts. I disembarked on the next Nizhgorodskaya station. The station looks like something made out of Lego. Nizhgorodskaya connects to a recently constructed transfer building. The transfer building connects Nekrasovskaya line with Moscow Central Circle and shall be connected in the future with Moscow Metro Large Circle line. Looks rather pretty, if you don't look too close. I actually checked the waiting areas, there were no USB ports there. Now, I wasn't sure if there are USB ports on the trains of Moscow Central Circle line, but went there anyway. The trains on Moscow Central Circle are Siemens D0 Rus that have been imported since 2011 for shorter intercity routes, and are used on Moscow Central Circle since the inauguration of passenger operation there in 2016. Those are nice trains, although I'm not necessarily convinced if they make sense for short-haul urban transportation. I walked the train all the way, but only found 220-volt sockets, no USB, and that was confirmed by a helpful train cleaner whom I stumbled upon and asked. Now, it was a good time to think of practicality of having public USB ports. In transport, the ports make sense, especially on longer routes. Even now I had to resort to a power bank. However, a public USB port is a vulnerability. Of course, the first thing that comes to mind to whoever is familiar with IT security is a possibility of accessing USB data lines. Theoretically, someone could utilize public USB chargers to push spyware or access data. This is harder to achieve in trains or buses kept in a shed, but seems quite easy at bus stops. While this is a possibility, another danger is reality. In 2017, transport enthusiast Arkady Gershman had reported that his iPhone was irreparably damaged after connecting it to a charger in Vitязь tram. Moscow government replied that the chargers are fine and provided no compensation. It actually happened live on camera. These are the main reasons why I avoid mysterious USB ports. However, asking everyone to carry a power bank is speaking with a privilege. The USB chargers in transport and even on the stops that I don't approve of prove to be helpful for many people, workers, travelers, even homeless. Then, if we consider that USB chargers do provide a common good, and as they are installed directly or indirectly using budget funds, the only sensible solution would be to ensure that the USB chargers are durable and provide safe and steady power supply, which we already established is not a given even at fairly recent installations. I recalled that when Moscow Central Circle had opened, some stations featured USB charging stations, and so I disembarked at Plochid Gagarina looking for one. A bum heating pad. The charging station at the station is located past the turnstiles, by the ticket office in between a recently installed hand sanitizer thingy and ticket machines. It features 8 USB ports and 4 220-volt sockets at each side. 16 USB ports and 8 220-volt sockets in total. 4 USB ports and 2 220-volt sockets of those are located lower for accessibility. Because I was just by the ticket office, I couldn't afford looking overly strange probing all the ports, and so I limited myself with random 6. The first port I had to rotate the camera for convenience, provided only roughly 0.5 amps at 4.8 volts. The nearby port had no power at all. The same can be said about the third and the fourth ports. The fifth port, like the first, provided 0.5 amps at 4.8 volts. The sixth did not really provide any current at all at 4.7 volts. On the second attempt, the first port tested only provided 0.2 amps at 4.8 volts. The charging stations theoretically should have much higher current than the ports in transport, because you aren't supposed to wait by the ticket office for anything. It's not even like a bus stop, and the only practical charging could be in a quick burst. The amount of ports, considering the small size of the charging station, also do not make sense. You definitely wouldn't fit 16 people for 16 ports, even 3 is problematic without even the social distancing. Given the poor results, the only reasonable explanation for that many ports would be added redundancy, as the engineers expected ports to fail. But even those that did not fail provide 0.5 amps at best. Perhaps the better solution would be engineering the station in such a way that it won't enter this sorry state just after 4 years of usage. Walking by Yuri Gagarin statue, I soon was at the stop for buses and trolleybuses. There are no more trolleybuses now, because the footage was taken a few weeks before August 25, 2020, when Moscow trolleybus was completely shut down. This trolleybus was one of the newest in Moscow, model BKM 321, built in 2017 in Belarus, a year after Moscow government began its destruction of trolleybuses. The route M4 was the longest remaining trolleybus route in Moscow before the destruction of Moscow trolleybus. I didn't know if newer trolleybuses had USB ports, but apparently they do, and 220-volt sockets as well. As passengers from nearby seats have left, I had time to explore the 2 ports. The port on the right did not provide good connection initially, but once it did, the result being at best 0.6 amps at 4.8 volts. The port on the left provided something closer to 0.45 amps at 4.8 volts. Knowing that Leninsky Prospect Avenue, on which the route travels, also has some electric bus routes, I left halfway by the St. Alexis Hospital. Turns out it was the last time I ever rode M4 trolleybus. Despite a fairly central location, the stops along the way were of a nice simple variety. While I was waiting, a bus had arrived, but I was determined to try out one of the new fancy electric buses. This electric bus, model KAMAZ 6282, was built just in 2019 and serves in the city since late October 2019. This time it was on the route M7. The city government is very proud of electric buses, writing "This is an electric bus" on the side of each one. The city government claims this is the next step after trolleybuses, but these electric buses have diesel heating, problems with charging, and overall are much smaller and less in numbers than disappearing trolleybuses. Like in the bus explored earlier, there were USB ports on double USB port mounts, supposedly providing 1 amp and 2.1 amps. The test had begun with 1 amp port, and it did not disappoint with actual 1 amp at around 5 volts. The 2.1 amp port topped at reasonable 1 amp as well, but did not provide the promised 2.1 amps. It is difficult to estimate which charging the devices affect the distance the electric bus can travel on one charge. The whole route was planned in such a way to incorporate Gorky Park, where, according to press releases of Moscow government, a few years ago USB charging benches were installed. Unfortunately, that day Gorky Park was closed off and guarded by the police and National Guard for an official high school event. However, it was a good opportunity to test USB chargers at a centrally located bus stop, adjacent to Gorky Park main entrance. Being all fancy, the bus stop had twice as many ports as other ones, but on a rusty panel and with rattling mounts. Turns out that none of the ports worked. They flashed blue but did not provide any power. The next steps weren't so certain, and so I improvised by crossing the bridge over Moskva River and waiting for a bus on Garden Circle Avenue. This was a good opportunity to test another, newer Liaz 6213.65 bus, built in 2019, serving on the route T10 since September 2019. The first test was of the double USB port mount. The results were good, similar to the ones achieved on other buses. A steady 1 amp at 5 volts at both 1 amp and 2.1 amp ports. Unfortunately, despite me waiting for a while, nothing higher than 1 amp was achieved on 2.1 amp port. As the seat in the front became free, it was a good opportunity to test out another charger, combined with a stop button. There are actually two ports, located really close together. It honestly surprised me as both ports passed the 1.5 amp test requirement, achieving 1.8 amps at 5 volts, peaking closer to 1.9 amps, the best result of the day. Perhaps closer proximity to the driver helped somewhat. After a nice 20-minute trip around the rainy city, the bus had terminated at Samotyechne Plochit Square. From there, it is a fairly short walk to an adjacent tram line, where the trams with spooky chargers could be found. This is 71-931M Vitis M tram, built by Transport Systems derivative of Tver Carriage Works. This is the third ever tram of this model, built in 2017 and serving since January 2017. This is quite a nice looking unit, even if seat placement and little details could use some tinkering. But I only realized when I was compiling this video that this is the exact same tram that burned the phone of Arkady Gershman, number 31003. Fortunately, the test did not burn the power bank and the meter, but it also did not exceed any expectations. The randomly chosen lower port provided 0.7 amps at 4.8 volts, and the top port provided an acceptable 0.2 amps, but later settling at closer to 0.4 at 4.8 volts. It's like all the electrons fell down to the lower port. The port mounts are quite fiddly and don't really look as fit for the task, with covers dangling and screws showing. The second port tested was even mounted in a different angle. Both ports settled at around 0.5 amps at 4.8 volts, better than burning your device, but not necessarily good either. The third charger tested disappointed with 0.1 amp at 4.7 volts at one port, and even less than 0.1 amp at 4.7 volts at another. The thing is, even if some of the ports do provide tolerable current, you can't just run around choosing which one is best, especially since sometimes seats can be occupied, and people don't usually carry a meter with them. The lowest realistic expectation is to have steady voltage and current at all of the ports, preferably something closer to what is stated if the amperage and voltage is stated. This tram on Route 7 traveled past Moscow Cathedral Mosque, past Moscow University Botanic Gardens, near to Japanese Embassy, and approached the square of the 3 rail terminals, before which I disembarked. The reason for such was close proximity to Kalanchovskaya suburban train station. The usual suburban trains are rather spartan, but since 2019 the station and the line have been integrated into Moscow Central diameters, and this meant that the line features more new rolling stock. Lines D1 and D2 were created by merging multiple suburban lines for seamless operation, and are supposed to serve similar to S-Bahn in Germany, RER in Paris, Overground in London, or suburban lines of Japan. Unlike the usual suburban lines requiring separate tickets, on Moscow Central diameters Troika card is accepted like in metro or trams and buses. More trains with lower intervals allow for more practical usage of the line within the city, and not for just commuting outside the city. The older rolling stock still serves the line, but the train that I specifically was waiting for was Aget 2TV, which, like many of the recent Russian trains, was named after a bird, Ivolga, after Oriol. These trains have been designed in 2014 and are built by Tver Carriage Works. There, I was lucky for the first arriving train to be the required one. The train features USB chargers right at the entrance area. The ones that look like as if you can buy those at a home improvement shop. The first port tried out, labeled 1 amp, did light up the meter, but did not provide any reasonable current and 4.7 volts. The second port, labeled 2.1 amp, provided 0.2 amps at 4.7 volts. So I walked to another charger. This one greeted me with a much more reasonable 0.8 amps at 5 volts, but not quite the stated 1 amp. The adjacent 2.1 amp port had a similar result. One of the issues of D2 line was experienced firsthand when the train approached Kursky rail terminal. It not only did so extremely slowly, but also waited at the terminal for a short while. Imagine if Yamanote line trains were to slowly approach Tokyo Station and then sit there for 5 minutes. Not very practical. The USB port placement is not very friendly for people sitting down. Only at a few spots you can connect without having to specifically stand in front of a charger. They also aren't accessible as they are located quite high. Before disembarking the train, I had a few minutes to test out the chargers in another car. The first supposedly 1 amp port only went up to 0.7 amps at 4.8 volts, and another supposedly 2.1 amp port went up to 0.6 amps at 4.8 volts. Another charger was the only one tested in the train to provide promised 1 amp at 5 volts at 1 amp port, but the neighboring 2.1 amp port only went up to 0.3 amps at 4.8 volts. I disembarked at Tekstilchiki station, which connects to Moscow Metro. There I noticed new information and emergency stations being installed. Those actually feature USB chargers too, and wireless charging as well, it seems. But despite them looking slightly beaten and dirty, they were new and not yet connected to power. I'll let it pass, maybe they'll be connected later. Tekstilchiki metro station sanitizer greeted me with dispersing not the hand sanitizing liquid, but an unpleasant sticky goo. Quite unpleasantly, it was nearing rush hour, and in the metro I expected a somewhat crowded train, which is not necessarily a good thing during the pandemic. This is Moskva series train, and it's on this line when my only practical attempt to use the chargers failed 2 years ago. Because of the crowds, it was difficult to find an empty spot to test the chargers, but it also was a good display on how plenty of people were actually using the chargers despite the drawbacks. The empty spot was found in the head car. The bottom charger had provided 0.2 or 0.3 amps at 4.8 volts. Note how the blue light did not turn red how it's supposed to do, and when I was about to test another port it finally did, to then turn off again. The next port also did not light up, and also provided similar 0.3 amps at 4.8 volts. The third port did light up, but these haven't changed 0.3 amp at 4.8 volt output. The top port was fiddly, perhaps from continuous usage, and had shown the same result. This exact train is just a year old. What shall be the conclusion? Here's a table showing all the results, and I was quite generous with rounding the numbers. If the port had stated current and voltage, it is written before the results. In total, 58 ports were tested. The green marks success, which means 1 amp current, with squiggly green marking current above 1 amp. Note that some chargers that provided 1 amp or even went above have not provided the stated 2.1 amps and did not go above the success threshold of at least 1.5 amps set for those ports. Only in one case, in a bus, nearly 2 amps were reached on 2 ports, and on another one port, the 1.5 amp threshold was reached with 1.7 amps. All the success cases that met the preset criteria are marked with a green circle. The yellow marks all the times the charger did work but provided current below 1 amp. The cases where the current was below 0.5 are also marked with a red line, because honestly charging at below 0.5 amps is extremely impractical. Even 0.5 is impractical. The red without yellow indicates complete failures. In total, there were only 7 successes according to the test parameters, with 11 successes total, which means that the chances to get a decent public charger are ranging from 1 out of 5 to 1 out of 8. Especially poor results were found at stationary installations, but the best came surprisingly from buses. All the tested chargers, including the completely failed ones, were at worst 4 years old. The test had shown that Moscow government and Moscow Department of Transportation, as it is often noticed, are only interested in showing off, and it does not matter if something works after the initial press release is published. The practical reasoning against and for public chargers have already been stated, but what the test had shown is a desperate need for proper quality control and continuous on-site inspection if the chargers are installed anyway. The ports should be constantly tested and fixed or replaced as part of the maintenance cycle by whoever is in charge of the installation. Otherwise, the installations can only be seen as lavish spending of budget funds on disposable electronics for propaganda of supposed technologically progressive nature of the government, and a gateway to corruption, as poor quality easily leads to contracts after contracts, like what can be seen in Moscow with constant repaving of the roads. There is definitely a room for investigation of reasoning and contracts, for example, behind stationary charging installations, as embezzlement is almost written on top of those. In any case, the only practical advice in regards to the ports is avoid. At worst, you will end up with a need to repair your device, but at best, or more accurately, at most times, you'll be just disappointed. Raccoon hugs everyone, remember to subscribe here and on Patreon, and remember to always return the leads of your multimeter to voltage position after measuring current.